So here we are. We've reached another real-world exercise. This one involves designing an elevator class that makes elevator objects. Now, you might think, what are the essential properties of an elevator? Well, this is the core of it. An elevator is going to have two main attributes and two main methods. The attributes are going to be the number of occupants it has. There's going to be a limit. Too many people can't use an elevator. And the floor to which it goes to. Again, that in itself is a limited range. So your job is going to be to design a class elevator. That class is going to have the attributes, floor, occupants. There's going to be two methods, add occupants and go to floor. Now, I will let you choose if you want to have a separate method for remove occupants, or you can add a negative number of occupants. But either way, your job is to make that method that adds occupants, as well as the method go to floor, restricted. So you can never have more than 8 occupants, and you can never go to a floor that is below 5 or above 50, because those floors don't exist. Now, the reason why I like this exercise and why I designed it this way is because these two methods are tied in with the attributes, and they limit how you use those attributes. They almost provide certain instruction and certain fail-safes. So let's have a go at this. You have a go first, then you can have a look at my solution. So here we are. Let's attack the elevator scenario. So what we know is that we're going to need to create a class with the following attributes. Occupants. So we're going to basically, every elevator is going to have an attribute for the number of occupants and an attribute for the floor that is on. So that makes sense. It's going to have methods for adding occupants and going to some floor. Finally, it's going to have these properties. Occupants can only be added if the occupants limit has not been exceeded. Only floors from -5 to 50 exist, so you cannot go to floor 100 when the building doesn't have 100 floors. So the first thing that I'm thinking, having read all of these, is this occupants limit. I think it's going, in the question I mentioned that it was 8. And we can either hard code an 8, or we can have some kind of a class variable for occupancy limit. I'm going to go for the latter because, you know, different elevators can potentially take more occupants. So I'm going to create a class variable, occupancy limit. And we're going to set that one to 8. Now, the init function, the init initiator, has to come next. And it's going to have the following attributes. So, occupants and floor. So, def init self, and we're going to have occupants and floor. Now, they're both set to 0 by default, so you can set them both to equal to 0. And in here, we can basically set self dot occupants equals to occupants, self dot floor equals to floor. Okay, and given that this limit is here, I mean, what if you want to create an elevator with number of occupants that's more than 8? We're going to need to basically put that limitation inside the init function. And that makes me think there's a couple of ways to do that. Maybe if I put the floor down here, I can do a little bit of an if statement that handles what if there's too many occupants, right? So you can say if occupants is less equal to 8, then self.occupants equals to occupants, or rather than 8, we created this class variable that we should be using. It's the occupancy limit. Oh, this is a class variable, so we're going to have to say elevator.occupancy limit. So if occupants is less or equal to the elevator.occupancy limit, we're going to set occupants. But what if it's more than the limit? Else self.occupants equals to elevator.occupancy limit. Elevator.occupancy limit. And what we can do next is maybe print out a message for the user. Print too many occupants. So we can basically say the user entered occupants minus elevator dot occupancy limit, comma, left side. I think we're actually ready to test creating some elevators, and maybe some elevators with too many occupants, and we'll see if this functionality we just put in, if it actually works, and if we get this print statement. So, creating elevators. So we'll just call an elevator, they don't have to have special names. Elevator 1 equals the elevator, and we'll put 6 people in there. But then for elevator 2, we're going to put 9 people. We're going to try to put maybe 11. So a couple more than the occupancy limit. So when I actually run this, I should get that print statement. Too many occupants. Aha. So that works. And if we print elevator 1 and elevator 2, and we do the same for the other one. What's up? Elevator. We never changed to elevator 2. Okay, there you go. So elevator 2 is actually got the exact occupancy limit. So not more occupants can go in, so you can never have the elevator with too many people. You can basically say too many occupants left outside. Alright, so now that we have created these attributes, we've actually put these properties on them, we can worry about creating these two methods. The methods are going to be add occupants and go to floor. So I'll just create them first. Occupants. So that one's going to have a number that you enter. So you're adding them. So you can add occupants, you specify a number, and here you're going to have to deal with the occupancy limit as well. I'm just going to pass this, and I'll put the other function in, and then we're going to tackle them one at a time. So the other one is go to floor. Def go to floor. So that one is going to have a floor that it goes to. So the add occupants method. This is again where we're going to have to do a test. Where we're going to add num to the occupants and then test if that's greater or equal to 8. And depending on whether the elevator is full, we're going to print out a message. So let's have a think about that. So we can basically say self.occupants, you can say plus equals to num. We're adding that num to the occupants. And here we can say the new self.occupants is greater than elevator.occupancy limit. Greater, if it's greater than, then we can basically say self.occupants equals to elevator. So if there's more than 8 people, we'll set that to exactly 8. And we will say print. We're going to have to print this beforehand. And then set it to 8. Let's see. Too many occupants. This is going to be self.occupants minus elevator occupancy limit left outside. So let's give that one a test. So we have elevator 1. It's got 6 people. So we can now say elevator 1 dot add occupants. We can add 7 people to it. So we should get 5 people left outside. Forgot to put pass in the go to floor function. Occupants. Yep, too many occupants, 5 left outside. That works. So adding occupants works well. Finally, go to floor. Now the limitations on go to floor are just that only floors -5 to 50 exist. So we just need a handle for that. So if floor is less than -5 or floor is greater than 50, then print floor, whichever number the user entered, comma, floor does not exist. And here's going to be an else. We're going to say set the floor, essentially self.floor equals the floor. Alright, so let's have fun. Elevator 1 and 2 are both full. Now we're going to send elevator 1 to floor 20, go to floor 20. When I print this, see, elevator 1 is at floor 20, but I'm going to send elevator 2 to floor 99. Go to floor 99, and it should actually print floor 99 does not exist. And the elevator stays on floor 0. So I believe we have handled pretty much everything specified. The only thing that could be added to this is remove occupants. So, when you get to a floor, you may want to remove a certain number of people. And then that should also have the limitation because you can never have less than 0 occupants. So let's just create that. I'm going to literally copy and paste this function and do some minor changes and make this work. So remove occupants, you're going to remove a some number of occupants. So you can say basically if self.occupants minus num is greater equal than 0. So if there's more occupants than you're trying to remove, you can say self.occupants minus equals to num. However, if you're trying to remove more people than there are in the elevator, else print else elevator, maybe elevator empty, and you can basically set self.occupants equals to 0. So if you try, even if you 2 people and you try to remove 10, we can set the elevator to empty, and we can just make this greater than 0. So now that we're on floor 20 with full occupants, we can elevator 1 dot remove occupants, and can remove all of them, 8. So it should say elevator empty. Excellent. And when it prints it, floor 20 occupants 0. And if we tried 2, it shouldn't print anything, occupants 6. And if we tried 99 occupants, it should still say elevator empty. All right, so there it is. Just to recap what the elevator class does, it creates an elevator with a class variable, a class attribute, occupancy limit. It has attributes in the init that are occupants and floor. These are set at creation with some limitation. You cannot add more occupants than the occupancy limit. Floor is set to 0 when the elevator is created. In fact, what you can do when you create occupants is completely remove the floor and set that to 0. Because let's say when elevators are created, they're created on the ground floor. So moving on, you also have methods for adding occupants. These have certain limitations. You can only add up to the occupancy limit. You can remove occupants, but these also have certain limitations. You can never have a negative number. If you try to remove more people than are on the actual elevator, you will set the number of occupants to 0. You have next going to a floor. This has limitations. You only can go to floors that exist. So I hope that overall this lengthy exercise has given you an idea of how methods can be used to really regulate what you do with the attributes. There's a tight control over what you can do with the number of occupants and the floor you go to, and this makes for good design.